Okay, good morning, class. Today we're gonna start your lesson 2, day 5. We're gonna talk about dilations on the coordinate plane. How we can locate dilation using coordinate plane, the XY plane, okay? But before that, we're gonna first of all a little review. Here, as you can see, we have AC to be 3 and OA to be 4, AA prime to be 12, OB to be 5, C to be 90 degree, which is right angle, M prime, A prime to be 65. So under dilation, corresponding angles are congruent. So if A prime is 65, so A has to be 65. So and then C, if C is 90, C prime has to be 90. So B has to be 25 because sum of angles in a triangle is 180. So 65 plus 25 plus 90 makes now 180. So it means B also has to be 25 degrees here as well. So how do we find the scale factor? So we know scale factor is always image over pre-image. So we're gonna find the distance OA prime. OA prime is the sum of OA and AA prime. So 4 plus 12, which is 16. And since the triangle A prime, B prime, C prime is the image and it's bigger than triangle AB, which is a pre-image, so we're going to have an enlargement here. So we might decide to take OA prime over OA, which gives us 16 over 4, which equals to 4. So our scale factor here is 4. So AA prime, since our scale factor is 4, so AA prime is going to be 3 times AC. So 3 times AC, 4 times AC rather, so it's going to be 3 times 4, 4 times AC, scale factor times 4. So 4 times AC, which is 4 times 3, which is going to be 12. Our AC is 3, so A prime, C prime going to be 4 times AC, which is 4 times 3, 12. And the B prime is the same as B, so they are going to be 25, 25, as we already have it on our two triangles. So BB prime. So if B is OB is 5, so OB prime will be 4 times 5, which is 20. So if you do 20 minus 5, BB prime will be 15. Then we're going to go to the business of the day. Under a dilation, the coordinate plane, a dilation on the coordinate plane with scale factor S and center of dilation 0, 0. So this is very important. This is an important point. So we'll take the point PXY, the pre-image PXY, to the image P prime as what? X times S and Y times S. So which means we multiply X and Y values by the scale factor, okay? Always multiply your X and Y values by the scale factor. So as example, we have something here. Our P guy here is 3 and 2. So the image of P, which is P prime, gonna be 3 and 2. And then we have to multiply each of these component, X and Y component, by the scale factor 4 here, this guy. So it's going to be 4 and 4. And 3 times 4 is 12. 2 times 4 is 8. So here we can see that we have an enlargement because the scale factor is greater than 1. On the other hand, since the scale factor here is less than between 0 and 1, less than 1 and greater than 0, so it means we're going to have a reduction. So let's go. We have G, the pre-image 10, 8, and the image of G, which is G prime. We're going to put 10 here, space, 8, space. So we're going to multiply both of them by the scale factor, 0.5, 0.5. What's 10 times 0.5? 10 times half is what? 5. 8 times half is what? 4. So as you can see, we have a reduction. G prime is half of G in terms of this component, in terms of X and Y. And P prime is 4 times P in terms of X and Y, okay? So let's continue here as well. Here our scale factor is 2, which is very important as well. As we can see, M here is at X component of M is 2 and Y component is 1. So if you multiply these two numbers by 2, 2 times 2 is what? 4. So you look for X being 4. And then 2 times 1 is 2, so you're going to have a point here that will represent M prime. You do the same thing for L. L is at X component negative 2, Y component 1. So negative 2 times 2 gives us negative 4, and 1 times 2 gives us 2, so you're going to have L prime somewhere around here. And also the K component is negative 1, negative 1. The X component is negative 2 rather, and Y component is negative 1. So we're going to multiply these two numbers by 2. So negative 2 times 2 is negative 4. So I'm going to come somewhere here. And then negative 1 on y-axis is times 2 is negative 2. So I'm going to have my K somewhere here, K prime. So then I'm going to join these lines. L prime going to join K prime. And also L prime going to join M. And M prime going to also join K prime. So my right triangle, which is the image, is bigger than the pre-image, is even twice. That's why we're going to write the coordinate of the vertex of the triangle, the transform triangle, are twice as far as 12 times as far from the center of dilation, and also the sides of the transform triangle are 2 times as long as the corresponding side, of the original triangle, as you can see clearly. And if when you check very well, you can see that these two triangles are similar in nature. We're going to do the same thing for the next problem. The center of dilation, the scale factor here is half. So I'm going to take V. My V component here is X component is 2 and Y component is 3. So I'm going to take half of 2, which is 1, and half of 3 is 1.5. So I'm going to have V prime somewhere here. My W guy X is 1, 2, 3, 4. Y is 2, negative 2. So I'm going to take half of 4, which is 2, and half of negative 2, which is negative 1. So I'm going to have W prime here. My U guy has X component to be negative 3 and Y component to be 3. So I'm going to take half of both of them, which is going to be negative 1.5, negative 1, negative 1.5 on X axis and 1.5 on Y axis. So I'm going to have U prime somewhere here. My T guy has coordinate negative 1 and negative 2. Half of negative 1 is negative half, and half of negative 2 is negative 1. So I'm going to have T prime somewhere here. So when I join these 4 points, I'm gonna have this the image gonna be the red figure here. So the coordinate of the vertex of the transformed triangle are 2 times as far from the center of dilation to, as you can see, and the side of the transformed triangle are also 2 times as far, as long as the corresponding side of the original triangle, or the original figure rather, parallelogram. Okay, so here it's a parallelogram, it's not a triangle. So you can see that the parallelograms are similar in nature. One is bigger than the other, but the corresponding angles are congruent and the corresponding sides are proportional. So what do we do here to just ascertain? Here we want to describe the transformation. Just take x component, the coordinate of x-axis -2, 2 rather on x-axis, and then on y-axis -1. And we are going to write s prime, the coordinate of s prime, and x-axis 1, 2, 3, 4, y-axis -2. So how do we move from s to s prime? As we can see, it's as if we multiply each element of s by 2. So here we can say x, y has been transformed to 2 times x, comma 2 times y. So here our scale factor here is 2. So we're going to do the same thing here as well. If I take c and c prime, c has x component at 1 and y component at 2. C prime has x component at half, so I'm going to write 0.5, and the y component at 1. So for us to move from C to C prime is as if we divided each x and y component of C by we multiply each x and y component of C by half. So I'm going to say here as well that x comma y has been transformed into half of x and y. So here the scale factor here equals to half, or 0.5. So that's all. Thank you very much.